located near the city of Cùzco. From above, this fortress has a saw-like shape. There was something there at the top originally, which was protected by the Incas. It's not clear what that was since there is nothing there now, but they built this saw-like fortress. And so the Ministry of Culture in Peru was very concerned about the megalithic masonry, where the blocks were very tightly laid together that you couldn't even fit a piece of paper through them. However, for some reason, the wall started to come apart. So the ministry was concerned about why this is happening and what could be done to stop this process. The first thing which was done was a scan using georadar. The Muscovites helped with this. The result was this image where we can clearly see the zones of fracturing. There were signs of sinking in the cross-section. In other words, underneath these constructions are either casts or some kind of cavities. The prevailing opinion is that these hollow cavities contain something which was originally being protected by this fortress. In parallel to these investigations, we also wanted to find out what kind of stone was used for the building of this megalithic wall. Surprisingly, there were never any microsections analyzed or any analysis whatsoever done on the blocks from this wall. What is interesting about this is that at first glance it seems to be limestone. Each block varies slightly from the next. However, on one of them I observed a flowing shape like this. On another there was a feature resembling a hand imprint. The other blocks looked normal. What was the matter here, we wondered. So we took some samples and brought them here to Khabarovsk for analysis. First of all, we determined that this is limestone. It successfully dissolves in various acids. All of these stones dissolve, leaving practically no remains. Here we took a sample from the masonry wall, and another sample was taken from the quarry where these stones are thought to have been obtained for the construction of this wall. Here are the samples from the quarry. It's clearly limestone. Not much more can be said about that. Here's what it looks like under the microscope. Any geologist can clearly see that this is organic limestone. It is practically all taken up by these organic skeletal remains. Here's another sample, also from the quarry area. Here we also clearly see these organisms, and around them is this cement which is neither transparent nor crystalline in nature, just as it should be in any organic limestone. We also took samples from the masonry wall. Here's what we saw under the microscope. Fine microcrystalline limestone. Almost not even limestone, but more like marble. However, marble in most cases is macrocrystalline, with large crystals in other words. But here we have very finely crystalline limestone material. In some places there's a vein running through it, which are kind of filled with this larger sized material. And so these are the plasticine stones among them here. Here you can see the masonry of normal blocks, and in the middle is this trout that cuts through them. This trout clearly has the flowing wavy shapes on the sides. So nature doesn't do that. Things like this. This is what plasticine stone looks like under the microscope. This is the clearest example of quote-unquote plasticine stone. In other words, this is very fine microcrystalline calcite-like rock. What kind? Carbonate, calcite in general. Here are the two analysis results side by side. On the left is the one from the quarry, and on the right is the one from the wall with those plasticine stones. Any geologist can see that these are practically the same material. There might be slight variations, a bit more calcium here, is organic limestone, and the second is the fine crystalline carbonate-like rock. They're the same, twins and brothers. However, in fact, these are two different materials. So here we have a question. What happened here? The simplest explanation which comes to mind is these Peruvians quarried this limestone, then pulverized it into a fine-grained powder, then roasted it to get quicklime, and then after mixing it with water, poured their blocks. The question is, how did they survive intact for over 1,000 years? Because conventional lime-based mortar wouldn't last this long. So, there were either some technologies which made them extremely durable, or maybe there were some kind of additives or something like that. Possibly if we do a more thorough and finer-tuned chemical analysis, maybe we can find out what it was. I mean, this is a very interesting question. These huge megaliths, and then how did they accomplish the construction itself? That's also not clear. Hypothetically, you would take a certain volume, pour in the mixture, what you got is what you got. And then lay a sheet of paper on top of it and pour the next block above it. And then every joint is practically non-existent, with both blocks very tightly fit together, without the need of any kind of polishing or cutting anything. Everything is perfectly formed. This is one of the problems, which unlike the question about the stones of the pyramids in Egypt, which are very theoretical, talking about aliens, that extraterrestrials came and built something, that and the other, this has very little bearing on anything. Yes, it's interesting, maybe it's true. But our question here, if we were to follow up and analyze it further to find out what it was that these additives were, would be very interesting. I mean, it could have very practical applications for us. This slide, we still have to analyze this, but as you can see, this gray mass on top of it is the plasticine stone. And then below it is the andesite. So some kind of an andesite surface, and then on top of it they molded whatever they wanted. The point of my report here is